This is the consolidation video for Unit D, Lesson 2. Our first question here is to give an example of an equation that is both linear and a partial variation. All right, so with a partial variation, this is an equation that has an initial value that is not 0. For one that is 0, we call it a direct variation. So a partial variation, it's going to have an initial value of something other than 0. So let's maybe say it's like C equals, 50K plus 100. Okay, something like that maybe, right? Where C is the dependent variable, right? That's usually what is on its own, right? Because it depends on the other variable. 50, that's your rate of change. K is your independent variable, right? That's the one that will determine the dependent variable. That's the one that kind of stands on its own a little bit more. And then 100 here, that is your initial value. So again, a partial variation is one that also has an initial value other than 0. Okay. Show and describe how to find the rate of change on a graph. Okay, so if we had a graph, right, and we have any 2 points, let's say it's like this. To find the rate of change between these 2 points, we draw what we call a rate triangle. Once you kind of get further, you might not actually have to draw it. You could kind of just do the important parts of the process. But we have this triangle. Once we have this triangle, we are interested in 2 things. What is the rise? What is the run? And that's what I mean, like, once you do a few of these, you might not need to draw the triangle every time, but it is kind of a nice way to see, okay, how is it moving horizontally? How much is it moving vertically? Okay, and then the rate of change is always rise over run, right? So how much is the dependent variable changing with respect to how much the how much the dependent variable is changing with respect to how much the independent variable is changing, right? Note that with this one, because it's going down and to the right, it would be negative, right? The slope would be negative, so whatever value we get for the rise would be a negative number, resulting in a negative rate of change. All right, so maybe I'll kind of draw these steps. The first step is we do a triangle. Second is you find the rise and run. And then the third step is the rate of change is rise over run. Making sure that your rate of change has units and it also has, it's in lowest terms or you've evaluated it. All right, so once you have your rise and run, if you can reduce the fraction, reduce it, or just evaluate it and round it. All right, next up here. Where do you find the independent and dependent variables on a graph? In a graph that looks like this, they are usually going to be labeled on the axes, usually as the titles on the axes, right? So one will kind of, be a vertical one will be the horizontal one, but which one is which? The independent is always the horizontal one. The dependent is always the vertical one. Right, so chances are if you look at those names on the graph, that will indicate to you what the dependent and independent variables are for your relation. Show and describe how to find the initial value on a graph. All right, so if you have a graph like this, and let's say you have a line that goes like this. Maybe this is something I didn't mention in the last time. If you did not have 2 points and just had a line, right, we would need to find 2 points on that line, ideally 2 non-sketchy points, and do our process. I guess I didn't really mention that. It kind of relies on you having 2 reference points. For this one, let's say you have reference points here and here. The initial value is where your relation starts, right? So when your independent variable is 0, what is your dependent variable? So we're usually looking at wherever our relation crosses the y-axis, right? So this value here, that is the initial value, right? And we say, like, when the independent is 0, what is the dependent, right? That will tell you what your initial value is. Note that as you move into more like trickier questions, your line might look like this. And you might have to work backwards using the pattern to find out what it is when x equals 0, or when the independent variable is 0. Okay? Next up, sketch an example of a graph with a negative rate of change. The good news is that's what we have been doing the whole time. A negative rate of change will go down and to the right. Right? So when we were to find the rise and run, the rise would be negative, the run would be positive, and then a negative divided by the positive would end up being negative, right? So negatives will go down to the right. Create a possible equation to represent your graph from question 5. Well, we don't have axes labels on these yet, so let's just invent some axes labels. Maybe this is like, maybe it goes up by 5s here, 10, 15, 20, 25, 30. And then maybe these go up by, let's say it goes up by 5, why not? 10, 15, 20, 25, 30. Let's say it's at 35. Okay. And just really estimating these points here. Okay, so we need to find the rise and run, because to make an equation, right, it's always dependent variable is the rate of change times the independent variable plus the initial value. So maybe I should write independent variable, and this is initial value. Okay, so maybe we also need axes titles. That might be helpful here. So maybe this is, meters. Sorry, this one would be meters, and this one is seconds, right? Maybe someone is running, they're jogging. The y-axis is meters, the x-axis is seconds. All right, so the dependent variable here, this is always our dependent. So we'll use m to represent meters. Our rate of change, let's talk about what our rate of change would be here. Our rise, this thing went from 25 down to 10. So this went down by it went down by 15, right? So our rise is negative 15. In terms of run, it went from, again, not exact here. Let's say it went from like 8 to like 22, right? So it ran 14. So our rate of change is our rise, negative 15, over our run, 14. Okay, so we'll put that in for our rate of change. Our independent variable is going to be seconds, right? S is a good letter to use there. And then the initial value is where your relation starts, right? So after no seconds have passed, where's this person starting? It's starting at 35. And that is your relation there. Okay. This was totally just a sketch. We don't know if these points were 100% accurate because I'm just drawing this. I didn't necessarily make a graph that was suited well for making the equation. But that's what your process will look like. Find the initial value, find the rise, find the run, then we can make the equation from there. All right, and that is your consolidation video for lesson 2.